My name is Emil Lurch. I'd like to welcome you to the Leveraging Cloud Transformation to Build a DevOps Culture Talk. Today I'd like to talk to you about DevOps culture and building that into your cloud transformation process, migrating systems from a traditional workflow to a DevOps-based workflow. Before I start talking more about the migration process itself, I want to kind of level set everybody on what it actually means to be practicing DevOps. There's a number of different definitions out there. Some people talk about agile for operations being what DevOps really is about. Some people talk about DevOps as automate everything. But if we go back to the foundation, Gene Kim, who is one of the founders of the DevOps movement, defines DevOps as the emerging professional movement for collaborative working relationship between IT operations and development staff. So he goes on to talk about basically creating higher value faster, delivering value to your business on a faster, more predictable schedule. Gene Kim also authored the Phoenix Project, which is one of the seminal books in DevOps movement. But he missed one thing in this quote, which is really talking about how to bring security into the mix. The Phoenix Project actually goes into security in great depth, but he doesn't really reference security in terms of DevOps. So there's a DevSecOps manifesto that goes above and beyond traditional DevOps. And they talk about bringing in security as code, security by design, and bringing the security team into the development process on an ongoing basis, making sure that they're not creating friction with the rest of the development and operations staff. So at the end of the day, we have security embedded throughout the software development lifecycle. And we don't have to make a decision at the end of a project when the security team comes in and does an audit, finds issues, whether to delay the project and miss our release dates, or go forward with the project and have a system that's less secure. So what I encourage customers to do as they're talking about DevOps is really bring security into that conversation. Why does DevOps matter? Well, Puppet Labs put together a State of DevOps report last year, and here's a few of the statistics that they found as they surveyed the industry for the impact that DevOps had on their organization. Basically, you get much faster release cycles, much faster development of value to the business. And you can do this whether your applications are greenfield, brownfield, or legacy. So how do we do DevSecOps? What are the levers that we can pull on in order to make this collaboration between development, security, and operations? There's a number of things, and as I mentioned earlier, some people describe DevOps as automate everything. Well, that kind of talks to the right-hand side of this slide. You can see from a technical perspective, a lot of the things that you see on there revolve around automation. And you've heard other people today also talk about automate, automate, automate. We are trying to automate everything, and that does bring together development, security, and operations. As we're developing infrastructure as code, as we're bringing security testing into our automated testing suites, we have a lot of collaboration going on between the teams. But you've also may have been in some previous sessions and heard people talk about bringing people together from a people and process perspective. And on the left-hand side of this slide, you see a lot of the things that you can do from that perspective. You can obviously reorganize your staff. You can create an organizational structure that enforces cross-discipline teams. If you don't want to go that far, you can create V-teams and have cross-disciplinary discussions throughout V-teams. Also documenting processes, your release processes, your testing processes. Finally, you can do things like rotation programs where you have the various disciplines move and do a rotation in each other's areas. Where what we're trying to do is break down the barriers to communication and have people understand the different challenges that the other disciplines face. You could even, as a very lightweight approach, just to get started, start to have social events, right? Just anything and everything that will bring people together so that they can talk and understand each other's challenges. From a communication perspective, Melvin Conway, back in 1967, noted that as he went through the industry and looked at both system design and organizational communication structures, that the two were very closely aligned. So you can see he came up with this quote that says, any organization that designs a system will produce a design whose structure is a copy of that organization's communication structure. I think it's important to note he's talking about communication structure and not organization structure here. So you don't have to necessarily reorganize in order to change the communication structure. Later on, as we really started to think about the Conway's Law and the implications to both system design and organizational and communication structures of an enterprise, the term inverse Conway maneuver was coined. And this was coined much later in 2010. But again, what we're doing here with the inverse Conway maneuver is really take the system design that we have envisioned and change the communication styles and structures such that it encourages the system design that we're really looking forward to. So do we, for instance, want a system where security is siloed off and we have a security subsystem that we have to talk to for all security things that are related? Or do we want security to really be embedded into everything that we do? Your communication structures are going to help dictate one or the other. And this will happen naturally based on both the organization structure and the other communication structures that are common. At Amazon, we went and we did create organizational structures to enforce cross-discipline behavior. So this is what I would consider to be a full DevSecOps approach. We created 2 pizza teams. These are teams that are very small. They can be fed with 2 pizzas. And those 2 pizza teams were accountable for everything. Development of the services, testing of the services, operations of the services, the security of the services. They have full accountability and full authority to do anything within their realm. As a result, their incentives are completely aligned throughout the process. They are one team, all pulling in the same direction. So you have typical enterprise IT environments that may not be working like this. You've got other teams that are working in a cross-discipline small area. So at this point, you say, how do I get from one to the other? Right? So DevSecOps maturity, from a DevSecOps maturity perspective, we came up with 5 different levels. Level 1, which pretty much everybody needs to do, is that you have some sort of version control system and some sort of configuration management system. Now, whether or not you have Git in your enterprise or Subversion, Mercurial, or RCS, CVS, or if you're just landing files in a shared file system, in some way, your organization is practicing version control, whether you know it or not. Same thing from a configuration management system perspective. So there's tools out there to do desired state configuration, Chef, Puppet, Ansible, OpsWorks in AWS, to provide configuration management. However, if you're not using any of these, your configuration management may be your server team that's responsible for the operation of your servers in production. That team may have tribal knowledge of the configuration that exists on the servers and where they're trying to get to. So one way or another, everybody's at least level 1. Level 2 talks about an infrastructure provisioning system. So you may have heard the term today, infrastructure as code. Infrastructure provisioning can be done through services like CloudFormation or Terraform from HashiCorp. They allow infrastructure as code, and they allow you to version your infrastructure the same way that you would version code. Infrastructure provisioning system may also be a more manual process. But at level 2, you've started to think about your infrastructure provisioning, and you've tried to make it repeatable throughout development, test, production. At level 3, now we're trying to make our builds more repeatable from environment to environment. So an artifact management system, you're taking your compiled code, your bundles of your deployable artifacts rather than your source code, and you're trying to manage them and make sure that they're repeatable and can be deployed repeatably throughout your various environments. At level 4, you have a build-in continuous integration system. So this, to me, is the backbone of most DevOps type environments. So your build-in continuous integration system is responsible for repeatable builds. It can be responsible for repeatable deploys as well. And oftentimes we have a code pipeline in AWS, or maybe the pipeline plugin for Jenkins that's responsible for the process of moving code throughout the lifecycle. Lastly, at level 5, we've internalized all this as an organization. Now we want to make sure that we're getting feedback in an automated manner from our system in production. So this can be feedback through the application itself directly from customers, or it can be feedback from our servers, and we're analyzing logs, things like that. Depending on where you are, embracing more and more DevSecOps principles, more automation. We can do that either in a greenfield or a brownfield environment. As Puppet Labs noted in the State of DevOps report, this can be done in any case. What I normally see is that organizations have a little bit of both, a little bit of greenfield and a little bit of brownfield. In a greenfield environment, it's very easy to say, well, we're going to have a pilot project that we're going to work on and provide DevSecOps throughout the system. I would encourage organizations to try a number of different approaches, different sets of tools and processes to find which set of tools and processes work well within the organization. Once you find that, then you can apply that to other projects moving forward. For brownfield, you need to gradually migrate in some DevSecOps principles. Large organizations, as I mentioned, usually have a mix. You usually pilot out on greenfield, find out what works best for your organization, and then backport those lessons learned into your brownfield systems. So getting brownfield moved forward from a more traditional type development lifecycle to a DevSecOps fully enabled, fully automated lifecycle usually involves the following 5 steps. First, we set up that continuous integration, continuous deployment server, as I mentioned. The next 3 steps are numbered on the slides, but they're really steps that are taken more or less in parallel. Development is going to work on automating the build process. Development and operations are going to work together to help automate deployments. A QA, meanwhile, is busy automating the tests, the test suite. They're probably working with security to make sure that security tests are part of the test suite that will be executed. And lastly, operations will automate infrastructure build-up and teardown, which I'll talk about in a little bit. Step by step, if we walk through this, it looks similar to the following. A lot of organizations don't have any DevSecOps practices. The process looks a little bit like this. So a developer will pick tasks from the project management server. They'll figure out what the next thing is that needs to be done. They'll go ahead and do that work, develop the code, submit that over to your source code repository, and then the process really starts kicking off from there. So they'll build it on their own workstation, deploy it into a test environment. As they do that, hopefully, they'll document what they did to deploy the software. But as many people in the room probably know, that tends to be haphazard at best. So they'll have the deployment documented. QA will then test in the test environment. They also need to test in the production environment. But there's a step in the middle there where the operations staff will have to deploy it to production. That often doesn't go well as they follow the deployment documentation that was done by the developers, who may have just assumed that operations would know to do a certain step, but it may not be clear from the documentation. So it's another reason why we have QA in there testing on the production server. The first step that we want to do here is put in a continuous integration server. So if you think back to the first slide on this, step one was put in a continuous integration, continuous deployment server in place. At this stage, we have a continuous integration server, and we've automated the builds. So development knows how to do the builds on their own workstations. They'll take those instructions, codify it, check that into source control, and get that running on the continuous integration server. Continuous integration server now is building the artifacts themselves, or itself, and it's doing so in a sanitized environment. Developers tend to have a lot of experiments running on their own local machines. They'll have extra libraries. They'll have different software installed. The build server will guarantee that what we're building is exactly what we're intending to build, nothing more and nothing less. So you can start to get some advantages of things like security hardening and less surprises when you deploy out to test. So we're developing we're migrating over to DevSecOps in a way that provides incremental value. The rest of this process stays more or less the same. But now we have a continuous integration server that can serve as the backbone for everything else we do. The next step, now that the continuous integration server is doing our builds for us, the developer was deploying to test. Now we can have the continuous integration server deploying directly to test. Again, we have more scripts that are in play. Development and operations are going to be working together to get those scripts running. One key point on this slide is that the developer no longer has to document what they did to deploy to the test environment. So while operations may be still deploying to production, you have the advantage now that they have scripts that are being run in the test environment, that they can follow those scripts. Maybe they're even running those scripts, but they don't trust the continuous integration server to do that yet. But they have something that's known to work in an environment within the enterprise. So the next stage is to let operations get out of the undifferentiated heavy lifting of just pushing code out to production. Our continuous integration server now needs to know or knows how to do that. Our deployment scripts have been tested several times by running it into the test environment. The operations staff may have also been testing this in a production environment to make sure that it works there as well. I've simplified this particular slide because the process is now the same between test and production. So now we're just deploying out to the application servers. The last stage, and I call this the last stage only because QA normally starts as soon as everybody else does in terms of automating their tests. But those are usually the hardest things to automate. And so having the continuous integration server actually provide the tests or run the tests on their own in an automated fashion is usually the last thing that gets migrated. Now our QA staff can go back and think more about new types of tests that they want to capture, possibly regressions that have been found that they want to put new tests in place, testing strategies and policies that they want to put in place. So our QA staff, again, gets out of that manual test mode and allows them to think about other things. And we have our continuous integration server doing all the hard work. Lastly, we want to consider the fact that we're operating in the cloud. So up till now, a lot of the things that I've been talking about are things that can be done on premises. But when you operate in the cloud, now you have the ability to create and destroy environments at a whim. You've created infrastructure as code, again, Terraform, CloudFormation. This server knows how to create its own testing environment. And so we're going to allow the continuous integration server to create the testing environment, run the test scripts, get the results, and then tear down the environment afterwards. This allows significant cost savings over what can be accomplished in an on-premise environment. So AWS tools that can help throughout this process. Source control, obviously, is a big piece of things. We have AWS code commit that can help store the source code, all the testing scripts, The infrastructure as code, your build scripts, your deployment scripts. AWS Code Pipeline. A code pipeline is really about tracking the code as it moves through various environments, making sure that all the steps have been completed in the order you'd like them completed. And then when we get to deployment, provisioning, and monitoring, there's a host of tools that can be used to aid in that endeavor. So Elastic Beanstalk is kind of an all-in-one solution. AWS OpsWorks is basically managed Chef, so it takes the place of Chef, Puppet, or Ansible. And then AWS Code Deploy for deployments, CloudFormation for infrastructure provisioning, and CloudWatch. CloudWatch will provide some monitoring services as well. Then we move on to various partners that can help with DevSecOps all the way through. So AWS Code Commit is still a relatively new service. GitHub is very popular in the industry. I've mentioned Puppet and Chef several times, HashiCorp as well, Ansible. So you can see the list of partners there. One concern that you might have, though, is around cost. So as we enable self-service and we're automating things, we allow development staff to just start creating infrastructure. They have to be responsible to also pull down the infrastructure when they're done, and that doesn't always happen. So individuals that's spending other people's money can sometimes spend too much. So we have a number of AWS services that can help out in this endeavor. So AWS Identity and Access Management can obviously restrict people from creating resources. And then we have a number of cost reporting, billing alerts, things like that are built as part of the platform. But this is an area where partners can really add a whole lot of value. And one specific partner that focuses in on cost control is Cloudability. And so I'd like to hand this over now to J.R. Storment from Cloudability, who can talk more about the finance side of DevSecOps.
Thanks, Emil. Yep. Can you guys hear me all right? I apologize in advance. We're tethered in here like on a leash, so if I fall off the stage, apologies. So my name is JR. I'm Chief Customer Officer at Cloudability. We're an Amazon partner, as Emil was saying. We focus on cloud cost management specifically, and that basically means helping companies to get better visibility as they scale into AWS and be more efficient and take advantage of cost savings opportunities. In my role as Chief Customer Officer, I get to work with a lot of some of Amazon's largest spenders and have been able to kind of be along for the ride the last 5 years or so as they've gone, companies like Adobe and Uber and GE, as they've scaled into AWS, and also a number of public sector organizations as well. And so we've seen some interesting trends start to develop, and a lot of the conversations we're having today, we weren't really having a few years ago, which is this combination really of DevOps and finance, both together at the table, having some very similar conversations, I think, to what Dev and Ops had when they came together when DevOps first started. And as Emil was saying, we see these things come in from DevSecOps, right? We've got breaking down of silos, we've got this collaboration between multidisciplinary teams, faster movement, constant adjustment to change. All of these things are mirroring what we're seeing as the finance teams get more involved with the AWS and with the cloud spending, because it's now becoming a more central, larger line item for them. And there's a whole new set of skills that they need to learn to actually work in this environment. And the output of this, unfortunately, in some cases, is that all this quick movement means that the cost goes up sometimes more quickly. Again, it's OPM, other people's money, as Emil was saying. And on the back of that, you end up with a place where you have some more complexity in the actual cost reporting that's creating some need for some new tools and processes. So the first thing that's driving that extra complexity is just this. AWS has turned out an amazing amount of products. I think in the keynote this morning, she said there were 70 major product families. Each of those product families has different ways that they bill. Each of them may have metadata associated with them, like tags. They might also each have different ways you can pay for them, like on-demand or spot or reserved instances. So there's a lot of detail in the way that maybe 10 years ago, or maybe not as far back for some folks, in a data center, you really just had a few major purchases you were making each year. And there was a really clear sort of sign-off process for that, and the budgeting was kind of straightforward. And that's all changed, and that's what's bringing this finance component to be much more involved with the DevOps teams. The other thing is that DevOps in general has really decentralized the spending. you no longer have those few big purchases. You've got a bunch of individuals, some organizations, dozens, sometimes hundreds of engineers or DevOps folks who are spinning up resources. And it's really driving this need for not only more education of the engineers to understand the impact of those actions, but also for the finance teams to get more involved in the day-to-day process as there's an iterative loop that's happening. Even further, you have CI and CD are really shortening the feedback loop. So, back to data centers, you were not doing continuous integration. You really didn't need as detailed feedback loops. You put out servers, and it took a while before you really had to increase the cost after that. So we're seeing now this more need for dashboarding and tools like this. And AWS has launched a number of these. We offer some of them. The ability to basically get feedback as you go, right? So as an engineer or DevOps person puts out resources, they actually need to see the impact of the cost on their actions right away. We're also seeing this mix of different disciplines of teams coming together, right? So traditionally, very siloed. The people doing capacity planning are going to be separate from the people developing the software, separate from the people accounting for it. And that's coming together ultimately into this new process. And actually borrowed this process from another slide that Emil had in an earlier presentation that he since took out, but the cloud software development process. But now we're seeing this setup where essentially you have DevOps on one side, and instead of the customers on the other side, you have finance in this loop. And the buy portion here is essentially an engineer or DevOps spinning up a resource, and they're deciding what to put out. And then hopefully the next step there in the measurement, they need to now look at that resource to say, was it the right one, right? Do I need to right size it? Do I need to adjust how many of them I have? There's a measurement step. And then it's ending up on the bill. And it's going to finance, who's not just trying to allocate it or charge it back, but now they're actually needing to take actions themselves on this. So typically that learn process is, well, what's happening with infrastructure now? Where's it going to be? And then what RIs, or reserved instances, do we need to buy? Or do we need to look at having a conversation about spot? Or should we look about consolidating to get the published volume discounts? And this loop increasingly looks more and more like what we're seeing with software, this build, test, release, plan, monitor, and repeat process. So we talked earlier about DevOps as the original descriptions that Gene Kim put out as part of the FinOps project. And I put out there's a new one that's emerging now, which is this FinOps idea. And we borrowed a little bit from Gene Kim's description here, adjusted it, but essentially it's now a collaborative working relationship between DevOps and finance as well that goes after the DevOps itself. And that results in an iterative, data-driven management of infrastructure spending. The idea there is to increase the cost efficiency and ultimately the profitability of the cloud environment. So this new world is basically creating a place where you have finance people sitting at the table with the DevOps people and with the capacity planners and the product owners as well. And specifically, we're seeing this role start to emerge, which is a person or small teams that's the FinOps czar. Sometimes it's the reserved instance czar, or the cost planning czar, but it's this person who sits there and works through the data as much as possible. Sometimes it's daily, weekly, monthly, depending on the scale of the organization, to find opportunities for cost savings. And it seems, like, well, that could be really, expensive, and we can't really put somebody on that. But when you start to look at the numbers, it gets pretty compelling, because just with reserved instance buying alone, you can actually save 30 to 60% on your EC2 and reservable portions of your bill. And assuming $1 million a year AWS spend, that's a pretty sizable savings. Typically, we don't see somebody dedicate a whole person to this, but it's something that you can put a little bit of somebody's time on. The idea here is that you want to have somebody who's really measured on the efficiency of the cloud infrastructure. It needs to be part of their job. Really notable, it's on the bottom, some of you probably can't see it, but it's typically not somebody in the engineering or DevOps org. It's actually increasingly somebody in the finance org, in procurement or vendor management, somebody who's got more of a data analyst, financial analyst mindset, who's looking at the data and constantly trying to optimize the rates with things like reserved instances. So how do you build that culture of this new collection of FinOps? First is just putting data in the hands of the people. Again, in that old school world, you had very short feedback loops, right? You had 3 to 6 months, 9 months lead times on data coming back in some cases, servers coming in. Now you can get that in front of people every day. You spin up resources, the bill changes, we need to show that to them. The next is remembering that cloud is new to a lot of organizations, and that there's actually a lot of good policies and evangelizing you need to do with folks, and it's really cross-discipline, right? You've got, in the same way with DevSecOps, you now need to educate teams across these different things. The DevOps teams, oops, lost the video feed there. The DevOps teams need to understand the impact of the bill, and the finance teams need to move from a world of just reporting on the spending to actually taking a really active role in the process. I'm going to pause for a second for the AV folks. Are we able to get that back? I think I remember my next slide. There we go. Okay. Cool. Thank you. Advancing here a little bit. Hopefully we'll get caught up. All right, almost back. Cool. So typically, as we've seen companies go through this process of putting in this culture of FinOps, they've gone through 5 stages, and similar to the 5 maturity steps in the DevSecOps lifecycle, people tend to start at one of these 5 and kind of work through them. So the first one is just visibility. It seems really simple, but in a world where you may have thousands of AWS instances and buckets and other resources, understanding what you're spending and what's making up that spending is the first key step. A few things you can do in this first stage. Get the information out to people daily. Cloudability offers some great tools to do that. AWS offers a ton of data that's available to process and do that with, but getting it out there so people can see the impact of their actions. You also want to make it open. Some teams are going to be better than other teams, so you want to encourage everybody to look at what the others are doing and make sure that those who are better are able to teach the ones who are still learning in the process, and put out broadly available dashboards. We offer some great tools like this that you can take advantage of that are dashboards that you can have for an engineer to look at resources, or you can customize it for a finance team to look at total cost per budget or team, or you could do an exec to look at the whole thing. There's some options to send out daily mails that update this stuff. The idea is get the information out there. The second stage, once we understand what the spending is to get into allocation. This consolidation of accounts that's coming together really means that now we have to separate out the spending to different groups and teams in a way we maybe didn't before. And you've got 2 tools that typically you have as an option here. You have linked accounts, which in this diagram are the blue ones on the left, and you've got tags on the other side. You can use either to allocate out costs, but each has some pros and cons. So the linked accounts are really the cleanest way to do it, because you know that with things in that account for that environment, for that product, for that team, should at least belong to that, and you can allocate it back. Now, tags actually offer much more flexibility. You can apply 10 to any resource at any time. You can change them over time. The issue with tags is they require compliance. You need your teams to tag things and to keep them up to date. And I will tell you, having sat through hundreds or maybe even thousands of infrastructure reviews with customers, very, very few companies are able to achieve that full tag coverage. Very few have that discipline. So we recommend definitely doing a mix of these things. Using linked accounts for the most important financial breakdowns, where you're saying, this environment lives in this account, and then use tags for the finer grain operational details. So, what's the role, the node, the cluster that this falls into. And as you're starting that allocating process, first and foremost, get everybody together to decide what are the things that you want to allocate against. Everybody's going to want to see it differently. Dev, ops, finance, execs. We do recommend letting the finance team take the reins on this a bit so that they can help direct the financial reporting, because it's sometimes the most strenuous that's needed. Next thing is get everybody aligned around at least a couple things that are mandatory, whether it's accounts or tags, but everything has to have a project tag, or everything has to have an owner tag. Automation is really the key here. If you want to be one of those companies that gets to almost complete tag coverage, you need to set this up in your build systems, in your deployment systems. You don't want to be chasing each and every resource and trying to tag it. We do offer some great tools to help you figure out what's untagged, lists of resources, buckets, anything else. So we can help with that if you get stuck in the meantime as well. And definitely look at putting in a tag or terminate policy. This can be really scary. If your instance isn't tagged, we're going to turn it off. Usually people start with like dev or test with this, but some of the most successful companies out there, Netflix is the glowing example, they run this in production. And your infrastructure should be able to be responsive to changes, and ideally this creates that culture where people realize this is really important. So once people understand where the dollars are going in that allocation phase, we typically get into efficiency. And this is really about not running the cloud like you'd run a data center. The thing to highlight, particularly for dev and test or staging environments, is that most of the month is actually nights and weekends. Now, it doesn't mean you can turn things off during all those times because you've got offshore teams or you've got things that take a long time to come back up. But you want to think about this as you're looking at your cloud deployment to say, we don't need to run things all the time. The beauty of AWS is that you can spin up whatever you need and then spin it back down. It's that second part that people often don't do as well at. So, think about building in this process and culture as you go, not just turning off unused things, but looking for underutilized things, looking for things that could be resized. There's a bunch of data coming out of AWS to tell you this. Our platform will take that data and give you recommendations and analysis and insights on the back of that. So take advantage of really, the beauty of Amazon, which is you only really need to pay for what you're using. A couple tips in this realm: automate the weekly waste reporting, or more frequently. Send out. We've got some report subscriptions you can set up to send things out to people to say, here's the stuff in your environment with your workload that looks to be underutilized. And again, share that broadly. You want to create some gamification here if you can. Create company-wide dashboards. One of the best things we've seen people do is come together in a monthly cloud center of excellence. Emil mentioned social events. Usually ours are more work, but maybe we should try adding drinks at the end. But the customers will get together with finance people and DevOps people and an executive sponsor to sit down every month to look at the RI buys, to look at where the waste was, and to get that process going and calendar it, because it's so easy to get focused on, I'm trying to get this migration done, I'm trying to get this feature out, and not actually think about the cost until it's further than you want it to be. So once you've gotten rid of things that you don't need, or hopefully downsize the things that are too large, this is the area you really want to think about savings. The biggest and most easiest lever here to pull are reserved instances. They're kind of the most straightforward cost optimization because they don't actually require any changes to your infrastructure, right? You can actually have a finance or vendor manager or procurement person reserve a series of reserved instances and drop the bill without your engineers spending any time on it. So that's really powerful, but you also need to make sure that the conversation has been had that, hey, we are running RHEL, we're going to stop running that, let's not reserve those. Or, hey, we're moving out of this AZ, we're going to stop doing that. Again, that process between DevOps and finance talking is really key here, so we reserve the right things and keep them up to date. And in this world of continuous integration or continuous deployment, your infrastructure is going to be moving around a lot, ideally. You're going to have a lot of refreshing of the infrastructure, hopefully a lot of changes, and your reservations need to keep up with that. Buying reserve instances, huge cost savings potential. Don't want to do it once a year. Don't want to do it twice a year. Do it every quarter, do it every month. We've seen companies do it multiple times within a month. You want to keep those things aligned as you go. And then on the back of that, after you buy them, there's a great thing called reserved instance modifications. How many people are buying reserved instances, by the way? Out of curiosity. Just a couple. How many have heard of modifications? All right, not so much. So modifications after you buy a reserved instance let you change them to be in a different AZ or be in a different size. They take a lot of the pressure and fear out of buying them because they give you a lot of flexibility to move them after the fact. So there's some really good options there, particularly Linux, to resize and move around. They make them a pretty safe bet over time. So one last thing I'll add on that last point. We hear a lot of fear from new people who've not bought RIs about committing to a year, committing to 3 years. If you look at the break-even points for these reservations, they're actually often like 3 months, 6 months. Even the 3-year ones are something like 9 months or 10 months. You don't have to think of it like you're getting locked in. With the flexibility of the modifications, with the break-even points, you really just need to know for that time cycle, 3, 6, 7 months, am I going to keep using these things? And the last thing is unit cost. So as you're doing your migrations, you may find that your bill keeps going up. And you may find that you're doing reservations and you're doing efficiency and you're surprised that your bill is still going up until you sit down and tease out that, well, you're using more, right? You have more applications coming in, your traffic's growing. So when you get to that point, unit cost is a really great way to start to tease out efficiency. What is growth in the bill from more migrations, more usage, and what is growth in the bill from inefficiency? And unit cost, as I'm talking about it here, is not a cost per server. It's a cost per some unit of value you're delivering. So it could be a transaction, could be a customer, it could be a cost per user or API call or page view. It's taking a business metric and taking your cloud spend and putting them together to say, what does it cost us to do this thing? And then tracking that over time. And you want to see that unit cost come down, even as your total bill may be going up because you're moving more into AWS as a way. And that metric in particular is a great way, if you have management or directors or leadership who are really concerned about the bill, to say, look, we're doing the right things. The bill's going up, but it's going up because we're moving it efficiently and effectively. So that's generally the process that we see people run through. To me, when I saw Emil's talk, I thought there were a lot of interesting combinations here. So I hope you guys found the same thing with the finance side of the house. If you have questions afterwards, we also have a booth at Cloudability. Happy to show you any of the stuff we do. Thank you for the time. Do you have any questions here that we want to take right now?
We have a few minutes. We can take some questions if anybody has any.
jumped the gun there.
Yep.
Talk about cross-functional teams.
Mhm.
With that, like, how do you ensure accountability? It's challenging. You make sure that who is accountable for what, 5 people at a time. Can you talk a little bit about what policies or what management processes you put in place to ensure that we still have someone accountable?
Yeah, so the question's around accountability of the teams when you have a cross-discipline team. Really, the accountability there comes down to the team as a whole. There will be, one person who's designated as the leader of that team. That can be, in some organizations, that may be a manager of a team that literally has a cross-discipline team. For virtual teams, that's often the project manager. Whether you're practicing Scrum and that's a Scrum Master, or it's a more waterfall type situation, that would be your standard project manager. But that's really where the buck stops, is with that leader. Yep.
So, from the perspective of consumption, I mean, we've managed the telephone long distance years ago. We managed the electricity that people were, or the amount of coffee they were eating and everything else. And the question becomes is, well, we're in this model now where we didn't manage it. And the CFO is seeing money bleeding out of the organization. We can't align that to a value. The question becomes is, at what point does this become a board level issue of managing this cost, and the organization now saying, hey, we want to purchase order cap, we want to spend a dime more, and how do we manage something like that in that environment because of regulatory compliance with some businesses?
It does happen. I mean, for any organization, there's a threshold, right, where this, whatever resource gets to the level where the board or exec team gets involved. We really see that split where the DevOps teams are the ones really who end up being most responsible for consumption. We see companies like really focus them on being the ones to reduce usage, and then the finance side of the house is ultimately talking about how to get a better rate for it. But in AWS world, it's not a cap world, right? I mean, cloud is not about putting the limit there. So that really gets back to, in my experience, getting everybody that visibility, understanding, so they know that the spending that's happening there is efficient spending, and that it's better than the world they're coming from out of the data center, and ultimately they've got that happening. The problem is we can't, like with anything, you need to bring them along for the story. So if they don't hear about it until it's crossing that threshold, it gets much more difficult to sell.
So follow up to that. Do you see an incentive model that should be put together for the users of a service like this, so that they're encouraged to reduce and build new capabilities and reduce the how they are using it? Do you see something like that? I mean, that's a whole different compensation model now for a developer, right?
I don't know if you necessarily need to do a variable comp for them on it, but it's definitely something you should align their incentives on. I mean, it's something you should measure because it's now a big part of the job, and it wasn't before. If you used more before, you just kind of had less resource in the data center. So it's definitely something that needs to be tracked and reported as part of management reviews and the individual's daily work.
I think we've got time for one more in the back.
Could you talk a little bit about the role of user interaction and user acceptance testing in DevOps?
Yeah, so the question's around user acceptance testing. So oftentimes in DevSecOps, what we're doing is we're providing incremental value. And by incremental, Amazon.com, for instance, is deploying once every 11.6 seconds all the way to production, right? So the incremental value that we're seeing is very small units. So typically for user acceptance testing, what we'll do is enable features that are under flags so that the users can actually go in and enable certain things that we don't consider really to be production ready. That gets deployed all the way to production, and then the users that we want to have do that testing will enable that flag under the knowledge that that is an experimental feature. And then they can play around with it and provide feedback before it's released really to everybody. And there's a couple other techniques. So you can do like A/B sampling and things that users aren't really in control of. But typically, if you want to have a targeted set of users, you would either have the flag that they control, or you know through your authentication authorization system that they're in a specific targeted group, and you can communicate with them in that basis. Yep. Well, that's all the time that we have right now. We'll be up here if you have any other questions. Thank you for your time.